Tonight's talk, Don't Stop Repeating Yourself, with Joel Holmes. Takes away.
Thank you, Colin, and thank you all for coming. Full disclosure, this is my first talk, so I'm very anxious, but I'm excited. So my name is Joel Holmes, as Colin has mentioned, and this is my first time here at Code Supply, and I think that, like he said, that this seems like a great place to be working in and coming to. So I'm saying this more on behalf of the streaming audience, assuming there is one. They should check this out more often. So I'm a software developer. I've had the pleasure of working at a number of different size companies at different stages in their lives. I've worked at a small startup that's grown to be purchased by somebody. I got to work at a fresh playground for myself to build whatever I felt like could help the company. I've been at large organizations dealing with legacy code systems and trying to lift products that were once meant to run on one server and run in a distributed sense. So I've had the ability to see a bunch of different places in this wonderful city, and I'm very grateful for that, and I wanted to share that because having these opportunities in the city, I think some people can take for granted. Coming up tomorrow, I wanted to one of these opportunities that is unique for our city is we're having a robotics Discovery Day tomorrow by the Pittsburgh Robotics Network. Jen Apicola was the one that made this connection for me to come speak here tonight, and so I wanted to pass along the thanks by saying, go check out Discovery Day tomorrow down at the convention center. It's free to enter, but you need to register. But you'll see some of the different robotic companies here in the city, education opportunities, manufacturing, so that it kind of runs the whole gambit. So please check this out tomorrow. Also, I wrote a book, Shipping Go. It came out in July. It's some of the stuff I talk about tonight will be coming from that, but it's more of an extension of what I've learned from this book in terms of writing it. So it was an interesting process. It was an opportunity to put myself out there, and I've enjoyed the whole thing that I decided I'm going to do it. I'm doing it a second time. This time I'm helping finish off a book, Refactoring to Rust. It's an excellent book that Lily already had started, and it really helps underline how Rust can be introduced into different ecosystems that have legacy code, how to improve that with the type safety, how to go from Rust to Python, and from Python to Rust, and all over the place. So I have 2 chapters near the end about WebAssembly, which is also interesting, but not as helpful as the beginning parts of the book. So so as I said at the beginning, right, I have had the opportunity to work at a lot of different companies. And no matter what company I've been working at, inevitably you walk into a room and you see something like this on a whiteboard, right? Like every job, everywhere I've been, I've seen this. And what is it, right? Is it a web service? Is it a web component? Is it a function, an API? Is it a whole application? Or is it someone just having fun drawing pictures on a board? The answer is it's an abstraction, right? It could be anything, and that's the way we think, right? That's the way we work. It's easier to draw a box and put a label on it so that we can kind of measure the space that it takes up in our entire system. And it's nice because it hides a lot of the technical pieces that we need, and with computers, it's all we are dealing with all the time are abstractions. From the compiler to the system architecture, we always are dealing with abstractions. So when we draw these boxes, what are we actually attempting to do? And I think that what we're doing here is we're establishing a process. So in our world, right, you have a problem, you write an app to fix it, you put it up on the App Store, or put it on an ad-riddled website, and you make $1 million by selling your customers' data. It's how our industry has worked for a lot of times, but I'm obviously being hyperbolic here. But as a person who wants to solve a problem, write an app, or make money, I have to come up with an initial idea. I need to have something that I can put out there, and this is mine. You know, I'm going to go off of the rebranding of Twitter and call it Chi Squared, the independent influencer social media application. But all it really ends up being is a set of inputs and outputs, right? We have to understand what it is we're building. This box is just our abstraction. We don't know, you don't know how I wrote my application. You don't know if it's a monolith, if it's a microservice, if it's running on Windows, Java, it's running Java. It's really what we are using to you have established this abstraction, and in this abstraction you have even more abstractions. You have, it is constantly going turtles all the way down, right? We are always doing that, but the question is, when we are developing this code, we are always being told not to repeat ourselves. We should not be having duplicate code or code that looks alike. You know, we should be always on the edge of making sure that that doesn't happen. Yet, I'm sure if we look inside this box, right, there are patterns that we can look at and we squint at and we see. It could be this kind of pattern or this kind of pattern, like it could be a monolith. It could be microservices. It could be a website, web components, whatever. But you're repeating yourself no matter what. Because we are lazy programmers, and that's what lazy programmers like to do, is they will go to a page, they'll copy it, they'll paste it, they'll do a search and replace of the name. Andy Hunt and Dave Thomas originally outlined this concept of not repeating yourself in their book, The Pragmatic Programmer. And the line that they use is, every piece of knowledge should have a single, unambiguous, authoritative representation in your system. So we have these boxes that are obviously something, they're abstract. We have to copy them, repeat them, rewrite them. And from my experience, we were talking about this before before everyone started coming in, is you have these premature abstractions that we try to create. We end up building systems before we know what the system is really supposed to be doing. I've encountered this by creating a bunch of individual databases for individual business entities that I thought existed, and then having to merge them back together because I didn't know that abstraction. It's been an extremely painful process. So, So how do we handle this? Your architecture is abstract or is agnostic to your system. Your architecture is your abstraction to your overall system, but you can't do premature optimization by making everything generic early. So it really does become a chicken and an egg problem. But as my sons have explained to me, the chicken and the egg problem doesn't make any sense, because chickens obviously came from dinosaurs, so it becomes a dinosaur and an egg problem. So with that in mind, with that evolution in mind, we should really consider constructing our abstractions to evolve, not be afraid of repeating, because that's what nature does. It repeats, our DNA splits, it reattaches, it splits, we get variation over time so that we can continue to have more robust systems and processes as animals. But as systems, we can do the same thing, right? We can implement what's called an OODA loop. So this concept is a military concept that came from the Air Force. And it stands for observe, orient, decide, and act. So whenever we're making a change to our system, when we're really analyzing what the next step is in its evolution, we should always be observing the pain points of those systems. How can we change and position those problems that we're experiencing in a way that we can make it an actual thoughtful decision that's going to improve our system over time, and then act on it. And this is how a lot of our modern day industry, manufacturing industry pieces, or manufacturing companies work, because they are companies like Toyota are watching their processes, watching the development, seeing where the pain points are, deciding what they need to do, and improving their system. But it's not we're going to sit down, we're going to re-architect our entire pipeline. We're not going to start from scratch. We need to change what we're doing over time. And this reflection, right, can't be part of just one person's job. It can't be the architect that's sitting up and saying, I think that we need to be moving to this cloud, or using this product, or using this type. It needs to come from within the team. The people who are writing the code, are working with the code and working with the processes and systems, or even as an organization, have conversations about where these pain points are and be able to elevate them, because that's the only true growth and true way you're going to understand how to improve your system over time. And as part of this, we find that it's important to support the other people in our company and other people on our team by standardizing the abstractions that we're making as we evolve over time. So to me, one of the most difficult parts of understanding an abstraction, and it isn't that we shouldn't be repeating ourselves, but the intention is that a repeated action should be standardized in the form of libraries and components. These abstractions are clearly defined interfaces that we can write. Like this service that I have defined here, we don't know, again, if this is an API. Is this an internal service to a Java application? What is it? All we know is it has a dependency, right? It needs to connect to implementation A or implementation B. And most developers at this point understand that having an interface adds an abstraction level that allows you to change and modify your system without it being tightly coupled and therefore breaking. So Barbara Liskov defining this as the Liskov substitution principle, and oftentimes it's taught in the context of, object-oriented programming. But I think you can really consider any sort of system where we're passing messages and objects around, in whether it's internal to a C++ application, or if it's on a bunch of gRPC methods that are going through a bunch of microservices. The principle remains the same, right? If I change my interface, if I change the gRPC definition, the protobuf definition, my system's going to break if people don't also update their systems. If I change the interface within internal to my Java application, it will break the system if it's not handled properly. So by working with our abstractions and understanding that the only way that we can enter our black box, right, is through a clearly defined interface, we can use that as the starting point for building a system that allows you to repeat yourself in an effective way. So, excuse me. When we look at how we define interfaces in our systems, and I'm going to lean more towards networking models rather than monolithic applications. That is not because of any sort of particular reason other than I work mostly with network services rather than larger monolithic applications. But the concepts remain the same. When we have a standard that we can all work with as a team or as a company, it makes it a lot easier for us to build tools and systems around those clearly defined interfaces and standards. So imagine, right, like we wake up tomorrow morning and someone swapped out all of the outlets in our house, right, but refused to plug anything in with, a European style plug. We wouldn't be able to make our coffee. We wouldn't be able to toast our toast, toast our bread. Um, or do anything in our house because someone has changed our interface. So we do this all the time, though, right? Like someone will say, "Oh, we should be using, GraphQL, or we should be using gRPC," and one team will be using one standard, one team will be using another standard. And not only will they be using those standards, different standards, they'll be using them differently. So what we should be doing instead is using this as, picking a standard that we should be using to communicate, and then using that as a stepping off point for empowering our developers to focus more on the code that they need to write, not the code, or they want to write, not the code that they need to write. So how many times have we gone to start a new application or new portion of a code, and we've had to reference the old code, look at different standards, look at how we copy and paste, like I said earlier, and do the replacements, and you end up having these systems that have typos and errors, and they really become difficult to evolve over time because they are so hacked together because of time constraints or whatever. But when Ruby on Rails came out, it really showed a lot of people the benefits of building code generators. I defined an entity through a YAML document or some sort of interactive template, and all of a sudden I can generate database tables. I can generate the accessor methods to the tables. I can have a basic app running within 15 minutes, which is amazing if you think about it, because empowering your developers to rapidly test and develop new products is exactly what most companies want. They want the innovation, they want the growth, they want the ability to do that make changes without risk. And oftentimes, we find that the reduction of risk happens because we can isolate the core code that we have, and we make improvements to the external pieces. The way we're handling our REST calls, the way we're handling authentication changes, but our underlying business logic rarely changes. So code generators then will allow us to change, if we decide to change our interface in whatever way, we can create a new code generator that will allow us to migrate to something new. If we want to move from Go to Python, or we want to move from Postgres to Mongo, it empowers us to move forward by standardizing the repetitive work. So code generators become a great standardization tool, and another task we end up trying to do over time in companies to help speed up and enhance our abstractions would be to create common component libraries and share functionality. This can be tricky because it can be very complicated, and when you're creating these common libraries and these common patterns, it becomes very easy to grab for something called, to grab for the F word, a framework. And a framework can be overly complicated and cumbersome to move, which I think, based on a lot of different companies and different areas that businesses start out and they find that they're struggling more with their framework in order to grow, rather than actually doing the work that they need to do. So you can have that kind of framework, or you can have this kind of framework, which basically doesn't support a whole lot. And I can't tell you what the right answer is. This is a team decision, right? If you want to be a Ruby on Rails shop and you want to have something that's very strong and rigid on how you develop your apps. No, excuse me, I've never done Ruby on Rails app. This is just from interviews I've had with people. Or you can have what barely acts as a framework, but is a loose structure. That all depends on your team and can be built into your code generators and built into your common libraries. I worked at a company one time that provided a WYSIWYG editor for developing a service, essentially a service mesh, and it was extremely difficult. It allowed you to dive down into the abstractions, but because I didn't know how the abstractions were formed, small code changes could end up breaking the entire system. So that was so rigid that it became impossible for me to do my job. But it was the standard that we had. On the other hand, I've worked with Spring and at other positions, and it allows you to really customize and really dive in and implement your own annotations around the classes and things like that, and it gives you a lot of power. But again, you are then inundated with too much flexibility, and it becomes difficult to manage. So it's finding that balance for you and your teams. Again, it's going through the standardization process so that you can reduce these problems over time and not have to constantly be thinking about them. And really what we want is this, right? We want to be able to ship out Holmes. We want to have a nice framework. We want to have a basic pattern. We want to be able to reduce all of the work that it takes for the initial setup and development of different features and whole applications, solely so that we can focus on the time it's going to take us to solve the actual problem. So when your boss is coming to you, you don't want to be saying, or they say to you, I want a new service for this feature stood up, how long is it going to take? And you'll start saying, well, I have to create a new service, I have to import the libraries, I have to create the database tables, I have to contact DevOps for how we're going to be deploying this. I have to go through this whole process. And so you're factoring all of these things in, but you know the task maybe only takes about 2 hours, and then you add another hour for testing. So what do? We sandbag, right? And sandbagging doesn't help really anyone other than gets someone off of our back for a little bit of time, hopefully. But what we want to be able to do is say, it's going to take me an hour to meet with the UI team to come up with an API definition. It's going to take, we're going to put that up for code review. As soon as that's reviewed, we're going to kick off a couple code generators, and we'll have the core piece of code probably delivered at the end of the day tomorrow. And this idea of reducing the amount of work you do for repetitive work comes from Frederick Winslow Taylor. He's a polarizing figure, mostly because when you're working in industry in the early 1900s, you tend to not have the best employment practices. However, I think sometimes it's important to look at what people do in other aspects, and he really was focused on the scientific aspects of measuring how people work. And I think if you really pay attention to how you as a team work and how you as a company work, you can really focus on standardizing the easy stuff, the repetitive stuff, and allow people to focus on the problems that they need to solve. So his rules for scientific management, I'm not going to read them all to you, but I really think if you can squint, turn your head a little bit, you can see, oh, I can do this with my software development as well. How many times have we gone through and we have maybe a half put together to-do list on how to set up a service, as opposed to having a nice, make file or make script that will set it up for us. How do we teach other people who are joining our team in order to make sure that they're being effective within the few first days of hiring? How often have we been given inexact or kind of vague idea of what actually needs to be done? and how do you divide? And how is your work divided? Who decides what you work on? How much is worked on? Is it one person? Is it your whole team? You know, all of these different pieces come together when we're trying to improve our system as a whole and looking at it as a system. Um, by replacing the repetitive drudgery and with automation and processes, it allows our brains to then also be a little bit more free and to work. Sorry. So when we're developing something, I think, you know, there are just a myriad of things that need to be done. You know, if I'm developing a new API, a new system, I have to think about all of these different pieces in very generic terms. You know, I'm at the point now, right, where me and my team have an established standard. We have established processes. You know, I'm inside my box, my abstraction box, and I need to add a new feature. And this is like what comes to mind, right? These are all of the things that blow up in a project manager's mind or a team lead's mind when they have to come up with something or develop a new feature. But if we think about how we repeated ourselves and the abstractions we created, suddenly we can see a flow through our development process. You know, you work with the team to define the entities, the items that need to be displayed, created, stored, whatever. Write the documentation, write the standard that you are going to be sharing between your teams. And at that point, you can imagine automation, automation, automation with a human touch, with a human touch, with a human touch. So all of a sudden, right, this very complicated process becomes a system that is complicated but has a natural flow through your system, through your level of work. And then the time to actually do the work becomes focused on the business logic, not the setup. And I do want to say, you know, with some of the automation things, we skip a lot of steps in testing, especially, and completion with components and database tables. There's so many little pieces that we skip over because we don't have the time, because we are repeating ourselves and not in doing things manually. So unit tests are missed, test cases are not properly defined, our components don't have all of the different, you know, clickable things that they need to be clicked on. So, and this only becomes more difficult over time, right? So you have your system, your 5-foot canoe, and next thing you know, it's strapped together with a bunch of other canoes. By implementing the standardization and coding practices that I'm talking about, it becomes more of a fleet of 5-foot canoes instead of this monstrosity that can become a legacy project that we all hop on. I really wanted to emphasize that because I have, again, worked in systems like this where you're diving into each individual section of that ship and it's different and you're not sure where you are, you're not sure how it impacts the rest of the system. And it can't break off, it can't move. It becomes it becomes extremely difficult to handle. And you always want to try to make sure that you're a fleet of speedboats or, you know, 5-foot canoes so that you can maneuver, you can break systems apart, you can move data around. So the last piece that I wanted to kind of touch on, because I think that I think it can go without saying that when we start talking about being able to do generic tasks, repetitive tasks, it ultimately will lead to a conversation about automation, and automation can always then lead to a conversation about artificial intelligence. And I know this is a very hot topic in the industry and every industry, and how artificial intelligence is going to impact the work that many of us do from, a thinking level. What I would be interested in seeing in the future is having patterns like this set up so that I can have a Slack bot, right, that I message and say, we need to define a feature that involves X, Y, and Z. Would you mind setting up a service for me? And that based on the systems, the processes, and the flows that we've already established as a team, all of a sudden that becomes much more robust, much more specialized for the task that we have at hand. And then I, as the developer, can still go in, make sure that the code works as expected, verify it, and it again empowers me to do more thinking, more work, more design, and work on the system to build itself, rather than just always having to go back and copy and paste and repeat myself. So I mentioned the artificial intelligence because I think at some point we can imagine that it gets us 90% of the way there for what we need to do for our products and for our teams. And that the 10% then can be focused on improving our system, improving our product, and ultimately helping our customers. Because that 10%, it may not be a sexy algorithm, it may not be a system improvement, but it could be an off by one error that the AI system may not have had a clue about. So at the beginning of this talk, right, I mentioned working for companies with a variety of sizes and paths, that what drew them together were these boxes. But when I really kind of started this talk originally in my mind, was that when I squint and I turn my head, every organization kind of looks the same, right? You end up implementing the same things over and over and over again at different companies, at different workplaces. You draw the same boxes, you draw the same lines. So I felt that there's no way to stop repeating myself. And then I realized that I didn't have to. That each time I did repeat myself, that repetition got refined. It got better. It grew. And it grew with me, right? It's going to be different with you. It's going to be different with you. Wherever you go, your abstractions are your own, and you take them with you, and you learn from them. And what's amazing about working with team members is they have their abstractions and you have your abstractions, and you get to share them and you get to grow with them. And I recently have, I was working in isolation, semi-isolation for a while. I was the only person really developing a product, and the team member came on, and it was nice to start having that feedback come in and to have my abstractions verified, to hear his ideas about abstractions, and bringing at the beginning of developing a whole new system that grew from beyond me. And we were able to leverage these kinds of these tools and tactics to make sure that there wasn't, as much friction, that we could, evolve our system together over time. So in the end, not repeating yourself can be a great mantra to live by in software engineering, but we do need to repeat ourselves so we can find out more. So, thank you everyone for your time.
Do you want to take some questions?
Sure.
Right. We can take maybe like one question from the room.
I have a question.
Yeah, sure.
I've never used something like it before, so can you just give a few comments on what it's like to do code generation for the UI itself? I can understand for SQL or for like APIs, but
Right.
what
So
does that look like?
yeah, so for me, when I started leaning towards using code generation, I was playing around with Go's templates. So they have a very powerful template structure, and I ended up we were writing, the UI components that I was writing were so repetitive. It was like, I need to list an object, I need to view an object. I need to list an object, I need to view an object, I need to create an object, I need to do whatever. I have clients, I have all these different pieces that, again, were just repetitive. And I found that, I was building a React app, so no matter what, these are mildly, these are components. They can be removed, or can be moved, can be extended, they can be whatever. So just having something that says all objects that I have, if I have a code generator, pulls my entity, creates a component that's just called view object, and that just has a table with all the properties listed. That's all it did, but it gave me a baseline to go off of. It handled all the state control. It handled all of the buttons if it was a create form. So that's where the code generator really kind of helped me there. My first code generator on the UI though was Ember, which kind of modeled itself after Rails on that.
So it would be useful for something like Next.js.
Yeah, I mean, I really think that I purposely didn't try to dive into any code examples, because I feel like these kind of processes can be applicable anywhere in any language. It's just wherever you see the repetition happening, really consider, is it something that can be a unified library? Is it something that I can write a code generator around? What is it that I can do to standardize it? And the answer could just very clearly be like nothing right now, but keep an eye on it. Yeah.
I can ask you just kind of a theoretical question, maybe. You mentioned AI. So how do you say, a lot of this, say, being able to develop sophisticated systems has really been, I think, maybe the providence of some very large companies, right, to build these, and really take advantage of, a lot of the, it requires a lot of people, a lot of resources to develop these, almost like that behemoth that you showed, right?
Yeah.
How do you think that it kind of levels the playing field for a small company or even a startup? How do you see AI maybe, leveling that playing field to where a startup can do some of these things that has only been really in the domain of some of these larger companies?
Yeah, I mean, my thought on that is you can really look at any sort of technology, right, and imagine what the impact was. So the guy who had the most horses, right, in the town was maybe a really important person, but the first person who got an automobile ended up having more power to do, a truck to haul things. So it really becomes then twofold. One, are the tools there for the small companies to try to enhance themselves, to do force multiplication as much as they can, and whether larger companies are willing to take that risk to do the same, because a larger company they'll be a little bit more conservative and they have a lot more people to worry about, where if you are a smaller company, getting a leg up any way you can, I think is huge. And that's where the small companies become the big companies. So
All right, folks.
okay.
I think that's good for questions.
Yeah.
And I think we'll call it there.
Right. Well, thank you everyone for your time and for this opportunity and for your patience. So thank you.